So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the keyword for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it. So welcome back to my channel. We're going to be dealing with lesson 12 today, which is the second day of exponent laws. We are still continuing with our aim. How do we simplify expressions by using exponent laws? Again, an 8th grade standard. So we're going to be talking about 3 new laws with exponents today. And the first law that we're going to be talking about is the zero power rule. So something you have to remember about this is anything to the 0 power is going to be 1. Anything to the 0 power is going to be 1. Okay, so that means if I have 1,000 to the 0 power, that equals 1. 403 to the 0 power, 1. 2 billion to the 0 power would be 1. So writing it in algebraic terms, we would have a to the 0 power equals 1. Not a bad rule. Okay, let's move on to the next rule. So the power to power rule. Basically saying if I have, let's say, 2 to the 2nd power, and then I raise that to the 3rd power. Same concept of repetitive multiplication, but with exponents. So we know what power we're going to be multiplying it to. So think of 2 to the 2nd power as your base, and then that's what you multiply 3 times by itself. So we have 1, 2, 3 times following that exponent. Now, following our exponent rules, if I do 2 to the 2nd power, really I can expand that out even more. I can say, oh, 2 to the 2nd power is just 2 times 2. 2 times 2, 2 times 2, 2 times 2. I can also go the route of saying, oh, I have the same base and I'm using my product rule, which basically says I take my base and say 2 plus 2 plus 2. Any which way you play that, you're going to get the same answer. So we have 1, 2, 3, 4, 5, 6. So we'd have 2 to the 6th power. Same thing here. 2 plus 2 is 4. 4 plus 2 is 6. So they are the same. So if you look at your exponents that are in your problem, a power to power, the key thing is here you're multiplying your exponents. So in algebraic terms, let's say we have x to the a power all raised to the b power. That means you take x to the a times b in order to get your answer. We're multiplying exponents. Let's go to the last rule that we're going to learn, which is our negative rule. Our negative rule is basically our exponent has a negative value. So that means, let's say 2 to the negative 3rd power. The negative exponent just means that you're going to be taking the reciprocal of the base, and the exponent stays with the base, original base. So, for example, 2 to the negative 3rd power, if I take 2, our reciprocal is 1/2, and the exponent stays with the base, the original base, as a positive. So this would be 1 to the 2nd, 1 over 2 to the 3rd power. And if you wanted to simplify, you can keep going. 2 to the 3rd power is 8, so 1/8 would be our answer here. On the other hand, let's say we had a fraction as our base. So let's say 1/2, and I'll take to the negative 1 power. Sorry, let's do 1/2 to the negative second power. So I'm going to take the reciprocal of the base, which is just 2, and I'm going to keep my exponent, which is 2, but in the positive form. So 2 to the second power is 2 times 2, which is 4. So if we have x to the negative a value, or power, 1 over x to the a power. All right, let's try this out. The goal when simplifying exponents is you want to get a positive exponent. So even though it might be simplified, if it still has a negative exponent, you want to keep going. And that's when you can include your negative exponent law. So number 1 is a power to power. So that means we're going to multiply our exponents. So we have b to the second to the fourth. So we have 2 times 4, which would be b to the 8th power. Number 2, this is a little tricky. Our negative 3 is attached to our variable, not our coefficient. So our coefficient is going to stay where it is. But our m, that is what we're going to take a reciprocal of, and that goes to the denominator, so m to the third. So number 2 is 4 over m to the third power. It's a little tricky. Think of it as your m and your negative 3. The negative 3 is a balloon. So your exponent is a balloon. And you have to see what is that exponent tethered to or attached to. If it's attached to that variable only, you can separate your coefficient. Let's say if your coefficient is in your parentheses and then that is to the negative third power, then you take the whole thing and move it to the denominator. All right, let's move on to 3 and 4. Try these on your own. There are some negative exponents, and check it in a little bit. Welcome back. Let's try number 3. So this whole thing is getting applied to that second power. So we have power to power. So I'm going to take the power of 2 and apply it to 3. So 3 to the second power times n to the second power to the second power again. We have k to the 5th to the second power. So I apply that second power to each term in the parentheses. So we have 3, n to the second, and k to the 5th. There are 3 terms, so it gets applied 3 times. So 3 to the second is 9, n to the 4th, k to the 10th. We're going to multiply 2 and 2 to get 4. We're going to multiply 5 and 2 to get 10. And then 3 to the second is just 3 times 3. So that is our answer. Number 4, here we have something interesting where you have 2 negative exponents. So you will be taking the reciprocal. So basically g is going to your numerator and your c is going to your denominator. So basically you're flip-flopping. So once I flip-flop, I have to make sure that I'm taking the correct exponent with it. So c is going to be matched up with a positive 4, and g will be matched up with a positive 6, since you already applied that negative of taking the reciprocal. And that's basically it. So make sure you have your keyword for today's lesson. Make sure you write down any questions that you have on this topic, and definitely ask me, try or practice, and I will see you in the next video. Bye.